Okay, I'm sorry I'm late getting this up. I've been sick. And so 2.2, I hope you've already done that. And so we're kind of going backwards to 2.1. In 2.2, you learned about all different kinds of functions and how to figure out how to graph them. In 2.1, you're just working with one kind of function, and that is the quadratic function. So when you have a function in the form f of x equals ax squared plus bx plus c, where a is not 0, that is called a quadratic function. And as you learned in 2.2, when you have a function y equals x squared, that is a parabola. It looks like a U or an upside down U. And so this is the kind of function we're talking about. When you see a quadratic, you know it's this. And if you put it in this form, f of x equals a times x minus h quantity squared plus k, you can find the vertex and some other things. So you have to use completing the square to get it into this form. And when you do get it into this form, you can tell the vertex. The vertex will be hk, where h is that number that comes right after the x in your binomial, and k will be the number on the outside. That'll be your y-coordinate of your vertex. So vertex is hk. If the number in front of the binomial, a, is positive, greater than 0, the parabola opens upward, and the vertex is going to be a minimum point. So if you take a look at that left diagram, that is a parabola that opens upward. The a in the equation will be positive for that. You'll know it opens upward. And the vertex is a minimum because it's at the bottom of the parabola. So that will be the minimum point of the function. And then, and that minimum point, that minimum value of the function is going to be whatever k is. Because remember, the value of the function is the y coordinate. All right, and then if a is less than 0, so if that number in front of the binomial is negative, then your parabola is going to open downward like the picture on the right. And the vertex is going to be at the top now of the parabola, and so that's going to be a maximum point. And the value of that maximum will be k. It will still be the y-coordinate of the vertex. It is the maximum value of that function, highest it ever gets. The axis of symmetry for parabola is going to be the line that goes straight through the vertex, the vertical line. And vertical lines are always in the form x equals something, and it will be x equals h because that is the x-coordinate of the vertex. Okay, so let's see if we can sketch this parabola. This parabola, thankfully, is already in the y equals a times x minus h quantity squared plus k form, where hk is going to be the vertex of the parabola. So if we look at this equation, first of all, it says determine whether the graph of the parabola opens up or down. All you got to do is look at this sign in front of the number in front of the binomial, and that will tell you whether it opens up or down. If it's negative, it opens downward. So this parabola is going to open downward. And now we want to identify the vertex. Okay, the vertex is going to be, this is going to be the x-coordinate of the vertex, will be the number inside the binomial. But remember, the standard form of the equation has a negative sign in there. So if you get your equation into the form where it is x minus something, that something is going to be your x-coordinate of your vertex. So for our vertex here, our x-coordinate is going to be 1, not negative 1. And then the y-coordinate of your vertex is just whatever that number is right there. Could be, if it's positive, it's positive. If it's negative, it's negative. So this is going to be our vertex 1, 8. So we can go ahead and graph that. And then we're going to determine the x and y intercepts. Remember, to find the y-intercept, you just set x equal to 0. So your y-intercept is going to happen when you plug 0 into the function. So f of 0, because remember, on the y-axis, x is 0. So put 0 in for x and see what you get. So negative 2 times 0 minus 1, quantity squared, plus 8 is going to be negative 2 times 1 plus 8, which is going to be 6. So this function crosses the y-axis at 6. So that's another point. So now we want to find the x-intercepts. The x-intercepts are when the function itself equals 0. So when we take the whole function, negative 2 times x minus 1 quantity squared plus 8, and set it equal to 0, that is going to tell us our x-intercepts. So to figure that out, you're going to have to subtract 8 on both sides and then divide by -2 and take a square root on both sides. So you're going to have x minus 1 is equal to plus or minus the square root of 4, which is 2. So x is going to equal 1 plus or minus 2, which is going to be 3 or -1. So you've got, it crosses the x-axis at -1 and 3. Okay, so we can sketch the function pretty easily now. We can see how that's going to look. And the axis of symmetry, remember, is going to be a vertical line, x equals h. And in this case, h is 1. It's the x coordinate of the vertex. So that's our axis of symmetry. It's always going to go right through the vertex. It's going to be a vertical line. And then the minimum or maximum value of f, remember, it is the y coordinate of the vertex. So you've got that vertex at 1, 8. So the maximum value, we'll just go ahead and say it's a maximum because this opens down. So the maximum happens at the vertex, and that value is 8. And the domain, so for this function, and for any parabola, a parabolic quadratic function, the domain is going to be -infinity to +infinity. There's nothing you can't put into this equation. It doesn't have any square roots. It doesn't have any denominators. So it is just -infinity to +infinity. And then the range, you can see that this function, the y value can be all the way to -infinity, but it can only go as high as 8. 8 is the maximum. So we would write -infinity up to 8, including 8. Okay, so this time we have a function, a quadratic function. You can tell it's quadratic because the highest power on x is 2, and therefore it is a parabola. This is not in the lovely form we were hoping for, which would have been f of x is equal to x minus h, a times x minus h, quantity squared, plus k. If we had it in that form, we would know what the vertex is, but unfortunately it's not in that form. It's 3x squared plus 12x plus 5. And the only way to get it in that form is to complete the square. Fun, fun, fun. So we're going to complete the square, but you can't complete the square unless you have a leading coefficient of 1, and this is 3. So first thing we have to do is divide everything by 3. So y over 3 is equal to x squared plus 4x plus 5/3. Now we are going to write this with a blank after that 4x, and we're going to write another blank at the end because whatever we add, we're going to have to subtract because we're working on the right side of the equation the whole time. And so we have to add something to get that perfect square binomial we're trying to get. And if we add it, we need to get rid of it because you can't just go around adding stuff to one side of the equation. All right, what do we add? We add half the x coefficient squared. The x coefficient is the 4 right here. And we want to take half of that and square it. So half of 4 is 2. Square it, and you get 4. We're going to add 4 and subtract 4. When we do that, the x squared plus 4x plus 4 is going to become a perfect square binomial, x plus 2 quantity squared. We learned about this pattern you would see when we learned how to complete the square, and that is why we chose the 4. And then to write it as a perfect square, it's just going to be x plus half the x coefficient, which in this case is 2. And then we've got 5/3 minus 12/3 is -7/3. So now we have it almost the way we want it, but this is y over 3. We don't want y over 3. We want just y. So we're going to multiply the whole thing through by 3 again. We'll have f of x is equal to 3 times x plus 2 quantity squared. And then we'll have -7. So that's x plus 2 quantity squared. All right. So now it is in the form almost that we wanted it to be in, because in the form for the parabola, you've got x minus h quantity squared. This has x plus a number instead of x minus a number. So we might want to rewrite that as f of x is equal to 3 times x minus -2 quantity squared minus 7. And now we can quickly see what our vertex is. The number next to that minus sign in that perfect square binomial is -2. So that is the x-coordinate of our vertex, and the y-coordinate is just whatever the number is outside the binomial, and that is -7. So there's -2, -7, that's our vertex. And then we want to find the x and y intercepts. The y-intercepts happen when x is 0. So if you go back to that original equation, it's a little bit easier. Just plug in 0 for x and you get 5 for y, so that we know this function crosses the y-axis at 5. Now, remember, the axis of symmetry is the vertical line that goes right through the vertex. And so we know that this parabola looks exactly the same on both sides of that line. And since 0, 5 is on the parabola, we know that the point on the other side of that axis of symmetry, 2 spaces away, will also be 5. And so we can go ahead and just put that there. All right, the x-intercepts, little more work to do on that. When we look at this equation, 3x squared plus 12x plus 5, we can see that it's not factorable. And so we can plug all that into the quadratic formula, or we can just go back and grab the completing the square that we just did and use that equation. So we'd have 0. We're setting the whole function equal to 0 to get our x-intercepts. So 0 is equal to 3 times x plus 2, quantity squared minus 7. And then we could add 7 to both sides and divide by 3. And then we'd have to take the square root on both sides and subtract 2. And then we would have to clean it up and make it -2 plus or minus the square root of 21 over 3. You've got to rationalize that denominator. All right, so our x-intercepts are those fun numbers. So somewhere around here, same distance away. Let's see, 1.5. So 1. Right there. All right, so you can see that that's about where those are, but not exact. Okay, so let's sketch the function. Looks like that. And then determine the axis of symmetry. We just did that. It's that vertical line that goes through the vertex, and that is going to be x equals the x-coordinate of the vertex, which is -2. And then the minimum or maximum value of f, this parabola opens upward, so it has a minimum at the vertex because the vertex is at the bottom, and that minimum is going to be -7. Remember, that is the y-coordinate of the vertex. The domain, as I said, for a parabola is just going to be -infinity to +infinity, and the range will be from -7 up to infinity. This doesn't get any lower than -7, but it does get to -7, so including -7 and then up to infinity. Okay, the vertex formula. Another way to find the vertex of a parabola is to use the vertex formula. It is derived by completing the square, which I'm not going to go through right now. So if you have a quadratic function, f of x equals ax squared plus bx plus c, the vertex of that function is going to be -b over 2a, comma, f of -b over 2a. So the x-coordinate of the vertex will be -b over 2a. And the way to remember that, if you know the quadratic formula, it's -b plus or minus the square root of b squared minus 4ac all over 2a. So if you just look at the -b over 2a, that is the x-coordinate of the vertex. And then if you want to know what the y-coordinate is, you can just plug the x-coordinate into the function and you'll find out. So that is the vertex formula, and we're going to see what that's useful for in just a second. Also, if you want to know how many x-intercepts a quadratic function has, you can use the discriminant of the quadratic formula. Remember, the discriminant is the number that's inside the square root part. And I'm just going to rewrite that again because it's so sloppy. So the quadratic formula, remember, is x equals -b plus or minus the square root of b squared minus 4ac all over 2a. That tells you the solutions to the equation ax squared plus bx plus c equals 0. And so that is the x-intercepts of a function. It's when the function itself equals 0, what does x equal? All right, so the quadratic formula tells us what the solutions to that equation are, therefore what the x-intercepts are. So if you take that discriminant, b squared minus 4ac, that's the stuff inside. If you take your function, plug it into there, and you get 0 for that value right here. So if b squared minus 4ac is equal to 0, then the graph of your function has one x-intercept, because that means if this thing is 0, then your only solution is negative b over 2a, because that whole square root stuff just disappears if it's 0. So there's one solution, one x-intercept, which is negative b over 2a. If the stuff under the radical, the discriminant, is positive, then you're going to get two solutions. You're going to get two x-intercepts, negative b plus the square root of b squared minus 4ac all over 2a, and negative b minus the square root of b squared minus 4ac all over 2a. So two x-intercepts if the discriminant is positive. If the discriminant is negative, you're also going to get you're going to get two values, but they're not going to be x-intercepts because they're going to be complex. You're going to get negative b plus or minus a square root of a negative number. And so therefore there won't be any x-intercepts because there are no complex numbers in the xy plane. The xy plane is only real numbers. So discriminant equals 0, one x-intercept. Discriminant greater than 0, two x-intercepts. Discriminant less than 0, no x-intercepts. All right, so we're going to look at the usefulness of the vertex formula. Sometimes it's a royal pain to find the vertex of a quadratic equation, a parabola, and it's much easier to use that formula. Remember what it was? It was negative b over 2a, and then f of negative b over 2a. And so we're going to use that formula in just a second. All right, a stone is thrown from a 100-meter cliff at an initial speed of 20 meters per second at an angle of 30 degrees from the horizontal. The height of the stone can be modeled by h of t is equal to negative 4.9 t squared plus 10t plus 100, where h of t is the height in meters and t is the time in seconds after the stone is released. All right, this is how projectiles act in real life. If you throw a ball, if you throw a rock, whatever, shoot a bullet, it will fly through the air in a parabolic path. So we have this stone being thrown in a certain way, and we have this equation that models what the stone does, how high it is at any time t after it's thrown. So, 3 seconds after it's thrown, if you plug that into that equation, it'll tell you how high off the ground the thing is. All right, so determine the time at which the stone will be at its maximum height. And we're assuming we didn't have this picture. I mean, we have it now. We could look at it and say, oh, yeah, it's when it's, after 1.02 seconds. It is at its highest point, which is 105 meters. Just going to use the equation to figure out its maximum height. And so it will hit its maximum height at the vertex of the parabola. This is a negative coefficient on your t-squared. And that tells me that the parabola opens downward. And so that means the vertex is the maximum. It's at the top of the parabola. So if I want to find the maximum height of that stone, I need to find the vertex. All right, so I've got that equation. A is negative 4.9 and B is 10. If we're looking at this as a quadratic equation, and C is 100. Right here, this equation. It is a quadratic. It is a parabola. All right, so to find the maximum height, we need to find the vertex. And the vertex can be done by the vertex formula, negative b over 2a, f of b over negative 2a. So b is 10 over negative 2a, so negative 2 times negative 4.9. That's going to be our x-coordinate. And then our y-coordinate, we'll take whatever we get for x and plug it into this equation right here and see what we get. So I'm going to punch that into my calculator, and I'm going to get about 1.02 for my x. And then I'm going to plug that back into the equation. So negative 4.9 times 1.02 squared plus 10 times 1.02 plus 100. If I add all that up, I get about 105 for my y. Okay, so the x-coordinate is the time since you threw the rock, and the y-coordinate is the height of this thing off the ground. So the question is, determine the time at which the stone will be at its maximum height. That's 1.20 seconds. Now it's going to ask us that. Determine the maximum height. Well, it's right there. It is 105 meters about. And then determine the time at which the stone will hit the ground. The stone will hit the ground when the value of the function is 0, because that function tells us the height of the rock. So when the rock hits the ground, the function, it equals 0 meters. So you would need to solve negative 4.9 t squared plus 10t plus 100 equals 0. You'd want to solve this quadratic equation. That's the equation right up there. If it equals 0, the height is 0, the rock is on the ground. To do that, you will plug that into the quadratic formula, which you know very well how to do. I'm not going to do it for you. And when you do that, you will get about 5.65 for t. You may also get a negative value, but t cannot be negative. It's time. So you will get about 5.65 seconds for when that rock hits the ground. Its height is 0.